Right, so in this video I'm going to have a look at complex numbers again. I'm going to have a look at plotting complex numbers on the complex plane, and might have a look as well at the modulus of complex numbers. So a complex number will look like this. It'll be a plus bi. It'll have a real part and an imaginary part. So for example, if we take the complex number 3 plus 2i, 3 is the real part, 2i here is the imaginary part. Now, when you want to plot complex numbers, you use something like, you use this here, which is something like the xy axis that we use in coordinate geometry. So you've got a real number line along here, which just goes from 1, 2, 3, 4, 5, 6, and so on up to infinity, 0, minus 1, minus 2, minus 3, and so on down to minus infinity. So this is just your normal number line here, normal real number line. Now, the y-axis here, equivalent here would be what's called the imaginary axis. And we go up in i's here. So you've got 1i, 2i, 3i, 4i, and so on. And you've also got minus 1i, minus 2i, minus 3i, minus 4i. So we can plot any complex number on this complex plane by just, if we take, say for example, this one here, 3 plus 2i, we'll call it z. We usually use the letter z when we talk about complex numbers. So we're calling this particular complex number z. We call it z1. 3 plus 2i is what we want to plot. So this is the real part here. So you go out 1, 2, 3 on the real number line, and then you go up 2 on the imaginary line. So it's 1, 2. So we're looking at a point here. So this would be our z1 here. Now if you take another one, let's say 3 minus 4i, we'll call this one z2. You do the same thing again. This is our imaginary number here. Sorry, this is our imaginary number here, minus 4i. This is our real number here. So let's go out 3, and then we go down minus 4i. 1, 2, 3, 4. So z2 is going to be here. So that's going to be our z2. Okay, so if we want to do another one then, let's say minus 2 plus 2i, we'll call this one z3. So that's just simply going to be minus 2 is the real part, so we go down here minus 2, and then we go up to, it's plus 2 on the imaginary line, so we put a point here, and that is our z3. And last one then I'll do is, let's say minus 4 minus 3i, and we'll call this one z4. So you go minus 4 on the real number line, so it's 1, 2, 3, 4, minus 4 here, and then minus 3i, so it's minus 1, minus 2, minus 3, so it's going to be here. So this is our z4. So that's how you plot complex numbers on the complex plane. Okay, next thing I'm going to do is just have a look at what's called the modulus of a complex number. Now, so this is modulus. So we're just going to have a look at modulus of a complex number. What does that mean? What exactly is it? Well, if you take, for example, this complex number here, the modulus of that complex number z1 is going to be the distance that complex number is from the origin, from here. So if you take that distance there, that distance there is going to be the modulus of the complex number z1. And z1 is 3 plus 2i. So z1 is equal to 3 plus 2i. So all you're really going to do here is use Pythagoras' theorem to work out that distance. Remember, if you drop a line down here, really you've got a right angle triangle here. So you've got 1, 2, 3 out to here. So that's going to be 3 out to there. It's going to be 2 up. So our rise here, if you like, is 2. Our run here is 3. So we got to work out that there. So you just use Pythagoras' theorem to work it out. 3 squared plus 2 squared will give us this distance here squared. So in other words, the square root of this, the square root of 3 squared plus 2 squared, the square root of 3 squared plus 2 squared will give us this distance here. And that's really what the modulus, where the modulus formula comes from. So the modulus formula, then, if you take a complex number a plus bi, the modulus, and we'll call this z here, okay, z. The modulus of z would be written like this. You just draw these two lines down here on either side of z, or you can draw them on either side of the actual complex number itself. But it means the distance that z is from the origin, and it's just simply the square root of a squared plus b squared. So if we take this one here, 3 plus 2i, a is going to be 3, and b is what's in front of the I, the coefficient of the I, if you like. In this case, it's plus 2. So a is 3, so this is, if you like, a plus bi. So our a is 3, our b is 2. So it's going to be the square root of 3 squared plus 2 squared. And you work that out and you get that distance there. So if we do that, let's see, it was 3 plus 2i. We want the modulus of that. That's going to give us the square root of 3 squared plus 2 squared, which is just 9. The square root of 9 plus 4, that's 9 plus 4, 13. So it's the square root of 13. So the distance between the origin and our complex number z1 is just simply the square root of 13 units. So that's modulus, just the square root of a squared plus b squared. Now, what we'll have a quick look at as well is addition and subtraction of complex numbers. So we're going to look at addition and subtraction. Of complex numbers. So how do we add and subtract complex numbers? So let's take a couple and we'll add them anyway. So let's take, again, we'll take 3 plus 2i, and we will call that z1, and we'll call z2, let's say 2 plus 4i. Now if we want to do z1 plus z2, that's just going to be simply 3 plus 2i plus 2 plus 4i. We want to add those two. All you do is add the real parts. There's a real part there, and there's another real part there. We're going to add those two. So 3 plus 2 will give me 5. We're going to take the two imaginary parts as well. So we got 2 of these i's and we got 4 of these i's. Plus 2 plus 4 will give us plus 6i. So when we add these two complex numbers, you just add the real parts, add the imaginary parts. Subtraction is exactly the same. So say we want to subtract those two, z1 minus z2. So it's going to be 3 plus 2i, and we want to subtract 2 plus 4i. Now it's very important in this case, make sure you put the second complex number in brackets, because you want to subtract the entire complex number, not just the 2. So it's important when you're subtracting two complex numbers, make sure you put the second one in brackets. So when you actually do that, then you get 3 plus 2i. When you take away the brackets, you get minus 2 and minus 4i. That's why it's important to put these in brackets, because if you didn't put the brackets in here, you would only subtract the 2. You wouldn't subtract the 4i. The 4i would remain as plus 4i instead of, in fact, it is actually minus 4i when you subtract it. So again, you just do the real parts first. So we're going to do 3 minus 2, which is 1. And then we've got 2i minus 4i plus 2i minus 4i. That just gives me minus 2i. So that's what we get when we subtract, add and subtract complex numbers. Now, the next thing I'm just going to do is multiplying complex numbers by a real number. So I'm going to take, so we're going to multiply now. Multiply complex numbers by a real number. Okay, so again, this is just the same as what you do in normal algebra. So let's take, again, if we take 3 plus 2i, and I'm just going to, again, we'll just call that z1. Okay, now if I want to do, let's say, twice z1, how would I do that? Well, it's just simply twice 3 plus 2i. You do exactly the same as what you do in normal algebra. You multiply this 2 by this 3, and then you multiply the 2 by the 2i here. And when you do that, 2 times 3 will give you 6, and 2 times 2 will give you 4i. So that's multiplying by a real number. Now, the last thing I'm just going to do is look at what happens to complex numbers when you add them and when you multiply by a real number on the complex plane. So if you take our complex plane again here, so let's take our real number line here, and we'll go, let's say 1, 2, 3, 4, 5. And this is our imaginary plane here. We'll go I, 2i, 3i, and then minus I, minus 2i, minus 3i, minus 4i, and here this is minus 1, minus 2, minus 3, minus 4. Now if I take a complex number, let's say 2 plus I, so I'm going to put a complex number here, 2 plus I, and I'm going to add a complex number to that. So let's take our complex number is, let's say, z1, and we're calling it z1, and it's going to be 2 plus I. Now I'm going to take another complex number, let's call it z2, and I'm just going to call that 1 plus I. I'm going to add these two together. So if I add them together, so in other words, I'm going to do z1 plus z2, that will give me 2 plus 1, which is 3, and I plus I, which is 2i. So I get 3 plus 2i. So where do I end up? Let's have a look. 3 plus 2i, 1, 2, 3 plus 2i, I'm actually going to end up here. So what actually happened here to this complex number when I added z2 to it? Well, I added 1 to the real part. Now this is the original complex number, so if I add 1 to the real part, what actually happens? Well, I end up moving it in this direction 1 unit. So I added to 2, I added 1. So to 2 I added 1, I ended up at 3. So I moved the complex number horizontally 1 unit. I also added one unit of I to the imaginary part. So what did that do? Well, it moved it up 1 unit. So I moved it diagonally that distance there. Okay, so I moved it over 1 and up 1. So that's what adding complex numbers does. It moves it over to the right or to the left this number of units, and then up or vertically this number of units here, whatever's in front of the I. So really what I've done there is translated the complex number, or transformed the complex number from here to here. I've moved it over 1 to the right, and then vertically 1 unit to end up here. So it's actually resulted in a translation. And that works for any complex number. So for example, if I take let's say minus 3 minus 3, so we'll take a complex number down here. So this is, let's move that up a little bit. So we're going to take minus 3 minus 3i. Now let's say and we'll call this one z3, okay? We'll take a z4 then, and I'm going to call that, let's say, 2 plus 3i. Okay, so if I add those two together, what happens? Well, I have minus 3 plus 2, so all I'm going to do is z3 plus z4, so that will give me minus 3 plus 2, which is minus 1, minus 3 plus 3, which will just give me 0i. So I end up at minus 1 and 0i. So minus 1 on the real number line, and I don't go up and down the imaginary line, so I end up here. So what's actually happened to my original complex number? This was Z3 here. I added Z4 to it. So what did I actually do? I moved it horizontally to the right 2 places. So I went over here 2 units. So 1, 2. And then I went up vertically plus 3 units. So I went 1, 2, 3 units up. And I ended up here. So I actually moved it. I translated the complex number that direction there. So it's resulted in a translation 2 units to the right and then 3 units vertically. 2 units horizontally, 3 units vertically. Okay, so that's adding complex numbers. Now what if I multiply a complex number by a real number? So let's take complex number again. Let's take let's say 2 plus no, we'll actually, you know what I'll do? I might just draw that out again. It's getting a little bit crowded there. So we'll just draw that real and imaginary. So this is my real line here, and this is the imaginary line here. So we went 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5, and along here -1, -2, -3, -4. And then up along here we got 1, 2, 3, 1, 2, 3, I, and down here -I, -2I, -3I, and -4I. So let's take a complex number then. Let's take 2 plus 1I. So I'm going to take this one here. So we're going to call it, again, we'll call it Z1, and that's 2 plus 1I. Now if I multiply that by 2, for example, okay, so I'm going to do 2 times Z1. That will give me 2 2s are 4 plus 2I. Multiply 2 by 2 will give me 4. 2 times 1 will give me 2. So where do I end up? I end up at 4 plus 2I, which is here. Now what's that actually done? Well, if you take the distance from here, from the origin to my original complex number Z1, this here is twice Z1. What I've actually done is double the distance from the origin. So I've doubled this distance here. The distance from the origin to Z1 has been doubled. So the distance from the origin to twice Z1 is twice that distance there. And that's basically what happens when you multiply by a real number. You end up doubling or tripling the distance or quadrupling the distance from the origin. So multiplication by a real number is the equivalent of a dilation or a stretching or a contracting on the complex plane. In this case it's a dilation. We've actually increased the distance from the origin. But say for example we took the same complex number Z1, which is 2 plus 1I, and we multiplied it by a number less than 1, say a half. So say we did half Z1. That would be half of 2, which is 1, plus a half I. That's what we would get. 1 plus a half I would put the complex number here, which is all I've done is half the distance from the origin, or half the modulus, half the distance from the origin. This was Z1, and this is half of Z1 here. So we've contracted in this case, whereas we've dilated in the other case. So yeah, I think that's it for the moment. I'll do another video later on complex numbers, but that's it for the moment.